Hello everyone. In this presentation, we're going to tackle a very common and important business challenge, managing constraints. We'll explore the theory of constraints and learn how to maximize profits when your resources are limited. This is all about finding your weakest link and managing it effectively to build a stronger, more profitable bottom line. Here is the path we'll take today. We will start by defining what a constraint is and why it's so critical to identify. We will look at the bottleneck effect to understand how the weakest link in a process determines the output of the entire system. We'll then dive into our main case study, introducing mountain goat cycles and their profitability puzzle. We'll perform the correct analysis to determine their most profitable product mix. After that, we'll discuss how to manage and elevate the constraint to further increase profits. Finally, we'll touch on some real-world applications of these concepts. So, what exactly is a constraint? A constraint is anything that prevents you from getting more of what you want. Every individual and every organization faces at least one constraint at any given time. It's a universal concept, and it's not just about manufacturing. For a student, your constraint might be the limited number of hours you have available to study for an exam. For a major airline like United, the constraint at a busy airport like Chicago O'Hare is the limited number of loading gates. For a resort developer like Vail Resorts, the primary constraint is the finite amount of land available for building homes and commercial lots. Understanding and effectively managing these constraints is absolutely key to optimizing performance. The constraint within any system is also commonly called the bottleneck. To visualize this, let's look at the process for surgery patients at an NHS facility in the UK. As you can see from the diagram, the process flows from a general practitioner referral all the way through to discharge, and each step has a different daily capacity. The clear bottleneck here is the surgery step, which can only handle a maximum of 15 patients per day. This has a profound impact on the entire system. No matter how many referrals are made or how efficient the outpatient visits are, the total number of patients who can be fully treated is capped at 15 per day. The bottleneck dictates the entire system's output. Therefore, if you want to increase the overall output of any system, you must focus your improvement efforts directly on the bottleneck. Now, let's apply this thinking to a business case. Let's meet Mountain Goat Cycles. They make two models of bicycle saddlebags, a mountain pannier and a touring pannier. Looking at their initial data, the mountain pannier has a contribution margin of $15 per unit, while the touring pannier has a contribution margin of $12 per unit. This leads us to an obvious question. If we have limited production capacity, which product should we prioritize? The common intuition is to favor the mountain pannier because it has a higher contribution margin per unit. But as we will see, this intuition can be wrong. To make the right decision, we need one more crucial piece of information. The plant's bottleneck is a stitching machine, and it has only 12,000 minutes of available time each month. However, producing enough of both products to meet full market demand would require 15,000 minutes. This confirms that the stitching machine is our constraint. Therefore, the correct metric for prioritizing products is not the contribution margin per unit, but the contribution margin per unit of the constrained resource, in this case, per minute of stitching time. Let's calculate that. For the mountain pannier, we take its $15 contribution margin and divide by the 2 minutes it requires on the machine, giving us $7.5 per minute. For the touring pannier, we take its $12 contribution margin and divide by the 1 minute it requires, giving us $12 per minute. The conclusion is clear. The touring pannier is actually the more profitable product because it makes much better use of our limited stitching machine time. Based on our correct analysis, we should prioritize the production of the touring pannier. Let's determine the optimal production plan. First, We'll produce to meet the full monthly demand for the touring pannier, which is 7,000 units. This will use 7,000 minutes of our stitching time. Next, we'll use the remaining capacity for the mountain panniers. We have 5,000 minutes remaining out of our total of 12,000. Since each mountain pannier takes 2 minutes, we can produce 2,500 units. The result of this optimal mix, 7,000 touring panniers and 2,500 mountain panniers, is a total contribution margin of $121,500. When a constraint exists, managers can often increase profits by finding ways to relax or elevate that constraint. Let's ask a strategic question. How much of an overtime premium would Mountain Goat Cycles be willing to pay for one more hour of stitching time? To answer this, we first need to calculate the contribution margin per hour for each product. For the mountain pannier, that's $7.5 per minute times 60 minutes, which equals $450 per hour. For the touring pannier, it's $12 per minute times 60, which is $720 per hour. Now, since the company has already met the demand for the more profitable touring panniers, any overtime hours would be used to make more mountain panniers. Therefore, the company could pay an overtime premium of up to $450 per hour and still increase its profits. This shows that the value of relaxing a constraint can be enormous. Effectively managing constraints is a key focus for most companies. There are several common methods used to elevate bottlenecks. These include working overtime on the bottleneck process, subcontracting some of the processing that would normally be done at the bottleneck, investing in additional machines to increase capacity, shifting workers from non-bottleneck processes to support the bottleneck, focusing business process improvement efforts on the bottleneck, and reducing defective units, which waste valuable time on the constrained resource. Let's summarize our framework for managing constraints. First, you must identify the bottleneck. Every system has a weakest link that determines its total output, and you must focus your attention there. Second, use the right metric. When a constraint exists, don't focus on the contribution margin per unit. The key to profitability is maximizing the contribution margin per unit of the constrained resource. Third, prioritize accordingly. You should always make the products that generate the highest contribution margin per unit of the constrained resource first. And finally, find ways to elevate the constraint. The value of obtaining more of that constrained resource is often extremely high, so find ways to increase the capacity of your bottleneck.